What? Did you guys hear that?
I did. That's new. They
I've never seen that before, heard that before.
Neither have I, and I use Zoom a lot.
Interesting. I'm gonna have to investigate that. That's kind of freaked me out there. Okay.
And you have a button that says that
now we have to
consent.
We have to consent to be recorded.
Really?
Yep. It says continue or leave class.
Oh my gosh, this is new. Holy moly. I don't know if
that makes sense. I often wondered about that because there are so many states that you can't record people without their prior authorization.
Yeah, that's a good point. Wow. That might, I have to look this up. This might be some interesting statistics. All right, writing this down. Zoom, recording, consent. Okay, so are we actually recording right now? Did everybody have to consent?
I did.
Okay. If everybody else could, so we could record this.
It says it's recording.
It does say it's recording. Okay. Yeah. Let's go for it and hope for the best. So I think I'll try to chop this out of a YouTube video later. Anyway, we did a whole bunch with inference, combining the central limit theorem with the way we were trying to do confidence intervals and hypothesis tests earlier using stat key. So we're getting, I hope we're getting better at the idea of what a confidence interval and the procedure to get one, the idea of a hypothesis test and the procedure to get one. I'm going to review the technical aspects of those procedures right now. And then once we review that and a couple homework problems, we're going to go on to inference for 2 samples. And there's a few different versions of that we're going to look at this week. And we've actually already been doing it with the help of StatKey. And you'll see once I put the formulas up for the 2 sample ones, we're going to be like, oh man, StatKey is such a blessing because the formulas are kind of a pain. I have to look them up all the time. They're rather complicated, but we can just plug them into a spreadsheet. And I'm going to share a spreadsheet today. So next, I have a file in Google Sheets. No, I have a PDF in Google Drive. There we go, that I'm going to share with you all. I'll put this in the YouTube video too. And so if you check out the chat, here's a link, and hopefully I have the share settings right. I believe I do. It's this right here, a copy of some notes I'm going to go over today. So these are all the formulas we went over last week with the idea of how to get either the confidence interval or how to get the p-values. So this is the shortest cheat sheet I could write for most of what we've done in the last 4 or 5 weeks. So I'm just going to go over this slowly right now. So over here. All right, so here's my notes. I'm gonna rewrite these in detail with you. So the kind of idea is once we get a problem, we're either trying to test a hypothesis or estimate something about a population. So if we're estimating something about a population, that's a confidence interval. If we're testing against some previously known values, that's a hypothesis test. And so these are everything we need to know to do those. And I'm going to do a couple of examples applying this in a second. But first, I'm just going to run through my train of thought on this. What's up?
Sorry.
Okay. So this is, again, inferential statistics cheat sheet, I guess we would call it. Screen is in the way. Get out of the way, Zoom. So I kind of was modeling this after the way StatKey is designed, and StatKey gives us a bunch of groups of things to do. And in the inferential version, we can either do a confidence interval, or we can run a hypothesis test, and StatKey groups them like that. As far as the confidence intervals go, either in there, we're going to run a proportion or a mean. So either we're working with some categorical data and we have a proportion based on that, or we have numerical data and we have an average from that. So proportion versus a mean. If it's a proportion, we're trying to make a confidence interval, that's always going to be the sample statistic, which is our p hat, plus or minus our magic z-score, which we'll look at in a sec, times the standard error. And the standard error for a proportion is that p hat times 1 minus p hat, our sample proportion, divided by the sample size, and then we take the square root of all of that fraction there. As far as the z-score goes, that's from a normal distribution. So our z star comes from a normal distribution, mean 0, standard deviation 1, right, normal. And we also have to know the confidence level. So we need to know those two things to get the z-score. When we think about the confidence level, that's the percent in the middle. So we have to look at the tails. So there's this idea we have alpha, the tail probabilities, that's always 1 minus the confidence level. And in a spreadsheet to get that z-score, that's the norm inverse. And for the norm inverse, it wants to know what is the left tail probability. So it'd be alpha over 2. And then we want to tell it 0, 1 for the mean and the standard deviation because we're looking for a z-score there. Now, if it's spitting out, if we're talking about the left tail, it's going to give me a negative number. So I usually take the opposite of that right there. So I turn it into a positive number for my formula up here. Or we could use stat key to come up with that. Another side note on this, I didn't write on my other page, is that this plus or minus thing right here, that's the margin of error, right? That's what we add and subtract to the middle of our interval, p hat there. So just some reminders that p hat, that's my point estimate for the actual proportion. And then the margin of error is just what we're adding and subtracting, that magic z-score times the standard error. So that's kind of the technical aspect based on the central limit theorem. How do we create a confidence interval for a proportion based on some sample data?
Will we get to have all these formulas for our final?
Absolutely. And one of the things we're going to try and do in the last week is together write down what we think the best information we need to know to quickly take the final, so we're not flipping through the book frantically trying to find stuff that's helpful. So we're gonna add to this as a group. So we're gonna kind of make group cheat sheet notes for the final. All right, mean, similar idea. The sample proportion for a mean isn't a proportion, it's a mean. Sample mean is X bar, right? So that's my sample statistic. Plus or minus, we use t-scores with a mean, and a t distribution is a special kind of normal distribution, times our standard error. And the standard error for a mean is the sample standard deviation divided by the square root of the sample size. To get the magic t-score, we use a t distribution, and we need to know the confidence level. As far as the confidence level goes, that's the percent in the middle. We need to know what the tails are to get the right endpoints. So we have to, again, consider our alpha is 1 minus the confidence level. And on a spreadsheet, we would take the t dot inverse. We give it the tail probability, alpha over 2, and then we give it what's called degrees of freedom, and that's just the sample size minus 1. And I'm trying to remember, does that spit out a negative number? What did I write back here? I didn't put a negative in front of it, so I guess I'm gonna have to go look at my spreadsheet for that because I can't remember. So let's see, confidence interval for a mean. We did human body temp last week. Let's blow this up a touch. And for the t-score, yeah, since I'm doing the left tail, it's going to give me a negative number, and I just negative it again to make it positive. So like the magic z-score, we got to take the opposite of that also. Make that red to stand out. Because we want the positive version of it. It really doesn't matter because we're doing a plus or minus. It'll just flip the endpoints. Or we could use stat key here. And just a reminder here, we're trying to estimate something like what's the average heart rate of a certain group of people? What's the average blood pressure of a certain group of people? What's the average length of a screw we're producing from this machinery we have in our company? Something like that. We don't know the true average. We're using this to guess at it. So we always have our point estimate. We think the average for the whole population is around what our sample says. So that's the idea of a point estimate, which is the kind of thing that they usually say in the media. And then maybe in the fine print, they'll talk about the margin of error. And then the margin of error is that plus or minus part up here, our magic t-score times the sample, or the standard error, excuse me. So that's how we make a confidence interval for a mean. We have a couple ways to do it in stat key, and then the central limit theorem gives us some formulas we can whip out in a spreadsheet, and we have the sample spreadsheet we'll look at again today. Next, hypothesis test. So hypothesis test is where we have this idea, and then we test the idea against some sample data. We're either going to use a Z or a T for the what we call the standardized test statistic, and that's always the sample statistic minus the null value over the standard error here. Let's see, got a chat, hang on a sec. Yeah, I will get to right tail. Right tail does not apply to confidence intervals, it applies to hypothesis tests. So I'll get to that at the end of this right here. So let's write it down. So either for a hypothesis test, we were doing a proportion, or we were looking at a mean. So a couple cases here to look at. Either way, we need what's called the standardized test statistic. And so the test statistic for a proportion, and again, the test statistic is always the sample statistic. Well, for a proportion, that would be p hat, minus whatever the null hypothesis assumed, so we would call that p, divided by the standard error. And the standard error is similar to the standard error for a confidence interval, except we believe that the null hypothesis is true, so it's got to be based on that. So this time the standard error looks a tiny bit different. We have to base it off the null hypothesis instead of the sample, because we're assuming the null is true. So that would be p times 1 minus p over n. Once we have the test statistic, then we can go find the p-value. And that's the probability that we get some more extreme data than what the our sample currently says. So p-value. And if we're going to get the p-value with a spreadsheet, then we're going to use the norm.dist. And spreadsheet formulas only do left tails by default, so we got to tweak them. So this is the left tail formula, where we enter the z-score that we calculated. Mean is 0, standard deviation is 1, and then we put a little true at the end, make sure we get the right calculation. This is for a left tail. Since this formula only does a left tail, we can flip it by doing a 1 minus, because it's a probability. Probability 1 is 100%. So we could do 1 minus that norm dist if we want a right tail. And we would enter in our z-score, 0, 1, true, and that would be for a right tail. If it happens to be a two-tail test, we just double one of those, depending on whether the z-score was negative or the z-score was positive. So if we're doing a left tail test, we better get a negative z-score. Just gonna make a little note of that. This guy right here is negative because we're on the left side of z's. And if we're doing our right tail, our z-score, it better be positive, otherwise we get some wacky stuff going on. Most likely we picked the wrong test. Otherwise, two-tail, we double either one of those. Otherwise, we could go over to stat key and use the stat key normal dist with the z-value. If we didn't want to use a spreadsheet. For a mean, very similar. The test statistic is sample statistic minus what the null says, but we use different notation for that. The sample statistic for the mean is x bar, right? That's the mean of the sample, minus what the null says, what's mu, the mean of the population, and we divide by the standard error. And standard error is actually the same as the confidence interval. It's the sample standard deviation divided by the square root of the sample size. To get the p-value here, we're going to use a t-dist. Like the normal distribution on a spreadsheet, it's left tail at first. So for the t-dist, I enter my t-score, and then it wants to know what the degrees of freedom are. That's always n-1, and then we get a true here. True, there we go. That's left tail. A few years ago, spreadsheets added a right tail version of this, so you didn't have to do the 1-. So if I have a right tail, I would do t.dist .rt for right tail, give it my t-score, n-1, true. Actually, this one doesn't need a true. 90% certain, but I'm going to double check with the spreadsheet. Hypothesis test mean. Yeah, it's just t n-1. Okay. So that's the right tail version. We have to make that decision, get the right formula. On the spreadsheet, I included all three versions of it. And then if I have to do a two-tail, I have two options. I could double one of the above, depending on whether the t was negative or positive. Or I could use the two-tail formula. So t dot dist dot 2t, and it wants to know what's your t-score, and it wants to know what n-1 is. The thing about this version right here, kind of like the right tail, if we're looking on the right side, it's assuming our t is positive, and for some reason it makes the same assumption here. So this is expecting a positive t-value. So often when I'm doing one of these on my own, not for a class for some reason, I just pick, if it's t is negative, I use this. If t is positive, I use that. If it's two-tail, I double either one of those. Because this negative positive thing always throws me. So if you accidentally put a negative number there, it'll just say, hey, error, I can't do that. And you just take the negative off. Or we could use stat key. T-dist. All right, so that's that, almost exactly the same as the page before. I wrote things a tiny bit different, but a little explanation going with it. So this is what we've been doing for the last few weeks, spreadsheet formulas and a little bit about stat key. Next, we need to do a couple of examples of this for review.